Hello, hi everyone. Welcome to the Student Brain. So today we are going to discuss about electric current. Electric current is nothing but the rate of flow of charge. Electric current is nothing but rate of flow of charge. Okay. So here we can see electric current. Electric current. So the rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. I equal to Q by T. Okay, so SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So now you can observe here. SI unit of current is ampere. So we are writing with small letters. And the SI unit of charge is coulomb. And the SI unit of time is second. Okay. So 1 ampere is defined as 1 ampere is defined as 1 ampere is defined as 1 coulomb per 1 second. 1 ampere is defined as 1 coulomb per 1 second. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So the rate of flow of charge is called electric current. Okay. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. So 1 ampere equal to 1 coulomb per 1 second. Right. Now, so we can see on 1 electron 1.6 into 10 power minus 19 coulomb. And 1 electron, how much charge is present? On 1 electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb, so 1 by 1.6 into 10 power minus 19. So then we can take 1 by 1.6 into 10 power 19. 10 power 19. So 1 by 1.6. So we can write. So if you do it, you will get 0.625 into 10 power 19. Then you will get 0. So we can say 6.25. 6.25 into 10 power 18 electrons are present in 1 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay, so that's enough. So once again, the rate of flow of charge is called electric current. I equal to Q by T. So SI unit of current is ampere. So ampere we can write a capital letter. So SI unit of charge is coulomb and SI unit of time is second. And here on 1 electron 1.6 into 10 power minus 19 coulomb. So in 1 coulomb 1 by 1.6 into 10 power minus 19. So 1 by 1.6. So we can take 0.625 into 10 power 19. So in 1 coulomb we can write. So 1 coulomb 6.25 into 10 power 18 electrons are present. So this is about electric current. And next one. So we will discuss about electrical elements. So related to this, so we have to do problems also. I'll explain the problems. Okay, so we'll do problems. So first one is cell. This is cell, positive terminal, negative terminal, cell. And second one is battery. Positive terminal, negative terminal is battery. Okay, so this is a battery. And the next one we are considering, third one is open switch. This is open switch. open switch. Okay, open switch. And the next one is closed switch. Closed switch. So I'm taking this the closed switch. Closed switch. Closed switch. And the next one we can take fifth one, resistor. Resistor. Okay, resistor. This is the resistor. Resistor. Okay, the device which is used to oppose the electric current in the circuit is called resistor. Okay, and coming to sixth one is rheostat. Rheostat, either like this we can do it, or we can do it like this also. Okay, so rheostat. Rheostat. Okay, so once again observe here: cell, battery, open switch, closed switch, resistor, rheostat. Resistor is a device which is used to oppose the electric current in the circuit. Rheostat is a device which is used to regulate the current without changing the voltage source. Without changing the voltage source. Okay, done. Next. So next one, ammeter. Ammeter. So positive term, negative, voltmeter. And next one we can take wire joining. Next, wire crossing. Okay, so this is a wire joining and this one is wire crossing. Next one, bulb. This is symbol for bulb. Okay, so ammeter is a device which is used to Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. Voltmeter is a device which is used to measure the potential difference. Wire joining, wire crossing, and bulb. So ammeter, we can say ammeter which is connecting in series combination. Voltmeter which is connecting in parallel combination. Okay, so these are the electrical elements. Now we will discuss about so electric circuit. We will discuss. We will discuss about electric circuit. Electric circuit. Electric circuit. So electric circuit is nothing but a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric circuit is known as an electric. Continuous and closed path of an electric current is known as an electric circuit. So here I am taking the bulb. This is the bulb and ammeter. Next battery, switch. Positive terminal, negative terminal, current is flowing like this. Okay, so current is flowing. You can observe. So first one is conventional current. Conventional current. Second one is electric current. Electric current. Electric current. So here, what do you mean by conventional current? Conventional current is nothing but the flow of positive charges is known as conventional current. Flow of positive charges. Positive charges are moving from So positive terminal to negative terminal. Okay, so here I am considering the positive charges. So positive charges, here electrons are moving from negative terminal to positive terminal. Okay, so conventional current is nothing but the flow of positive charges. Positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. Okay, so this is about conventional current and electric current. And here one thing, so conventional current, okay, so positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Once again, conventional current. Conventional current is nothing but so positive charges will move from high potential to low potential, whereas electrons are moving from low potential to high potential. So the flow of positive charges is known as conventional current. Flow of electrons is known as electric current. So I hope it is very clear. So this is about electric current. So electric circuit. Now, so we will discuss about potential difference and electrical potential. Potential difference and electrical potential. Potential difference. Potential difference. Potential difference. So potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Within the conductor, okay. So I am taking here, so like this is a point A and this one is a point B. So we are doing, so positive charge, we are doing some work. Okay, work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Coming to electrical potential, electrical potential, electrical potential. So electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field. So I am taking this infinity. This is the required field. Okay. So we are bringing unit positive charge. We are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Okay, so once again you can observe. So potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field. Okay, so this is about the potential difference and electrical potential. So now we will discuss about next we will discuss about Ohm's law. Ohm's law. So Ohm's law is nothing but the potential difference across the ends of the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. So Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. V is directly proportional to I, V equal to IR. Okay. So now now. So now we will discuss about materials required. Materials required. Materials required. So what are the materials required? First one, materials required. First one, 4 cells. 4 cells. Second one, resistor. Resistor. And third one, ammeter. 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 And coming to fourth one, voltmeter. Voltmeter. Fifth one, 4 cells, resistor, ammeter, voltmeter, switch. And sixth one, connecting wires. Connecting wires. So now you can observe here. Okay, so the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So V is directly proportional to V equal to IR. Materials required: 4 cells, resistor, ammeter, voltmeter, switch, connecting wires. Okay, so procedure to do it. Procedure. Okay, first you have to connect one cell. So I am taking 4 cells. 1, 2, 3. 1, 2, 3, 4. So ammeter. So resistor, we have to take resistor. Switch. So here I am connecting voltmeter. Okay. So positive terminal, negative terminal, current is flowing. Now you can observe. First connect one cell. First connect one cell. Okay, so you have to connect one cell and note down the reading of ammeter and voltmeter. Second one, connect to 2 cells. Connect to 2 cells and repeat the process. So you have to measure. You have to observe the reading of ammeter and voltmeter and repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay. So once again observe carefully here. Ohm's law. The potential difference across the ends of the given metallic conductor at a constant temperature is directly proportional to current flowing through it. V is directly proportional to V equal to IR. Okay. So materials required: 4 cells, resistor, ammeter, voltmeter, switch, connecting wires. Okay. So first you have to connect one cell and note down the reading of ammeter and voltmeter, and connect to 2 cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4 and you mention in the tabular form given below. So I am drawing the tabular form. So you can mention in the tabular form like this. So here you can see serial number, number of cells, number of cells, ammeter, voltmeter, V by I equal to R, V by I equal to R. Okay, so we can take so 1, 2, 3, 4, 1, 2, 3, 4. Okay, so here you can observe after observing the ammeter reading and voltmeter reading and mention in the tabular form given below, and you can draw the graph for VI, V on y axis, I on x axis. So the graph is straight line. So straight line for ohmic conductors, and you can see for curve it is for non-ohmic conductors. So V on y axis, I on x axis. Okay, so the graph is curve. Okay, so observe carefully here. So Ohm's law is nothing but, so at constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to IR. Meters required: 4 cells, resistor, ammeter, voltmeter, switch, connecting wires. First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect to 2 cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4 and mentioned in the tabular form given below. So here you can observe. So serial number, number of cells, ammeter means current, a voltmeter means potential difference, V by equal to R. So V on y axis, I on x axis, VI graph gives the straight line. Okay. So ohmic conductors. So ohmic conductors are nothing but the conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. For non-ohmic conductors, the graph is curve. For ohmic conductors, the graph is straight line. Okay, so this is about Ohm's law. Next one, so we will discuss about difference between resistance and resistivity. Okay. Now, difference between resistance and resistivity. Resistance, resistivity. Resistance and resistivity. So resistance is nothing but the phenomenon of opposing the electric current in the circuit is called resistance. Okay. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. So R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So here resistivity rho equal to RA by L. Resistivity rho equal to RA by L. So here you can observe SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter. So meter get cancel, ohm meter. So resistivity is equal to ohm meter. Okay. So here you can observe resistance. So resistance depends on temperature, and resistance depends on material of the conductor. Material of the conductor. And here you can observe resistivity depends on temperature, and resistivity also depends on material of the conductor. Material. Okay, so material of the conductor. So I hope it is very clear. Just check once. Okay. So once again you can observe resistance. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. So here, so R is directly proportional to L, R is inversely proportional to area. RE is directly proportional to L by R equal to rho into L by A. And here you can see resistance depends on temperature, resistance depends on material of the conductor. And coming to resistivity, so resistivity equal to R, rho equal to RA by L. Okay, SI unit of resistance is, okay, so SI unit of resistivity, SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter, meter get cancelled. Okay, here you can observe, so rho equal to meter, so rho equal to ohm meter. So resistivity depends on temperature, resistivity depends on material of the conductor. So very important. So definitely 3 marks question. So 3 marks question, definitely it will be coming in exam. Okay, so not only this differences, so they may ask these 2 points, resistance depends on length of the conductor or not. And here also you can see resistivity depends on temperature and material of the conductor. Okay, so here resistivity does not depend on length and area of the cross section. Okay, so it depends on temperature and material of the conductor. Okay, so I hope it is very clear. And so resistance depends on length of the conductor, nothing but physical dimensions. So we can say physical dimensions, physical dimensions, physical dimensions. Okay, and resistance depends on temperature, resistance also depends on material of the conductor. So very important, make sure that you are preparing this one, these differences and these points. So that's enough. Next one, so we'll discuss resistors are connected in series combination and resistors are connected in parallel combination. Resistors are connected in series combination. So I am connecting now, so you can see. So 1, 2, 3. So 3 resistors, R1, R2, R3, R1, R2, R3. So 3 resistors are connected in series combination. 3 resistors are connected in series combination. So across R1 we am connecting V1. Across R1 I am connecting V1. Across R2 I am connecting V2. Okay, across R3 I am connecting V3. So this is the potential difference. Okay, so you can observe. So ammeter, so you can observe R1, R2, R3, R1, R2, R3. So across R1 I am connecting V1. Across R2 I connected V2. Across R3 I connected V3. Okay, so current is flowing. Current is flowing from the battery. Okay, so here you can observe throughout the circuit current is same, because so all resistors are connected in series combination. All resistors are connected in series combination. So throughout the circuit current is same. That is Is equal to I1 equal to I2 equal to I3 equal to I. Okay, so current is same. Current is same. Now from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. If I am taking V equal to IR, V equal to IR from Ohm's law. So I equal to, so Vs equal to V1 plus V2 plus V3. So you can observe here carefully V1 plus V2 plus V3 because potential difference is different. So current is same throughout the circuit, whatever the current is flowing, throughout the circuit same current is flowing. But potential difference across R1 is different, potential difference across R2 is different, potential difference across R3 is different. So from Ohm's law we can take V equal to IR. Okay, so equivalent potential difference, potential difference in series combination. We can also write V effective, V equivalent, V series. So Vs equal to V1 plus V2 plus V3. Then, so we can write like this. IRS we can write IRS equal to IR1 plus IR2 plus IR3. So here I am taking I common. As we know, so I is equal to I1 equal to I2 equal to I3 equal to I. So that's why overall in this, so here everywhere, so instead of writing I as I1, I2, I3, so directly I substituted I. Okay, so we can also take here, so I'll write one more step. So here you can observe, I'll write one more step. Directly same step will come, but still, so IRIS equal to RS and I1 R1 plus I2 R2 plus I3 R3. So we know this, right? IS equal to I1 equal to I2 equal to I3 equal to I. So that's why I am writing here instead of IS, I1, I2, I3, I am simply substituting so I. So then we can write IR1 plus IR2 plus IR3. So now you can take I common. So we can take I common. After removing I, so here I am taking IRS equal to I am taking common R1 plus R2 plus R3. So I get cancelled. I am cancelling it. So now RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. So overall resistance, okay, overall resistance in series combination RS equal to R1 plus R2 plus R3. So if I am writing if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, R is equal to NR. If n number of resistors are connected in series combination, R is equal to NR. Because you are connecting n number of resistors are in series combination. That's why, so R is equal to NR. So here you can observe these all resistors are connected in series combination. Now, if resistors are connected in parallel combination, so how it will be, we will see. So if n number of resistors are connected in parallel combination, so how it will be, we will look into that. So I am taking now 1, 2 and 3. Okay. So R1, R2, R3, R1, R2, R3, R1, R2, R3. Now this is I am connecting to the battery. So ammeter. So battery I am connecting. Positive terminal, negative terminal. Current is flowing. So across this one, So I'm connecting potential difference. So here, so the current is dividing into parts. So here I'm taking current I, that is dividing into I1, I2 and I3. Okay, so current is dividing into parts. Now you can see here, throughout the circuit potential difference is same. Okay, so here across R1, R2, across R1, R2, R3 potential difference is same, correct? So R1, R2, R3 V is same. So then we can take Vp equal to V1 equal to V2 equal to V3 equal to V. Okay, potential difference is same. Potential difference is same. So across R1, R2, R3. Now from Ohm's law, V equal to IR. Ohm's law is V equal to IR. I equal to V by R. I equal to V by R. Right? Now, so I'm taking IP equal to I1 plus I2 plus I3. Okay, so current is dividing, right? Current is dividing. Current is dividing, right? So R1, R2, R3. So I1 through R1, I2 through R2, I3 through R3. So now current is, now through whatever the current is flowing through here, so that is equal to I1 plus I2 plus I3. So that's why, I'm taking V by Rp equal to Vp by Rp, that is nothing but V1 by R1 plus V2 by R2 plus V3 by R3. So now I am taking, so here you can observe, V1, Vp, V1, V2, V3 equal to V. So that's why I am writing. So V by Rp equal to V by R1 plus V by R2 plus V by R3. V by R3. So now you can observe, so I am taking V common. If I take V common, 1 by Rp equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So V will get cancelled. So remaining values are 1 by Rp equal to 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so we can see 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3, right? If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. So if we want the Rp value, simply we can take Rp equal to R by n. Rp equal to R by n. Okay, so I hope it is very clear. Just check once. Now you can observe. So three resistors R1, R2, R3, three resistors are connected in parallel combination. So current is flowing. Voltmeter is connected across R1, R2, R3. Okay, so throughout the circuit, so current is flowing here. So here it is dividing through R1, I1, through R2, I2, through R3, I3. Now, so IP equal to I1 plus I2 plus I3, right? So that we are writing. So V by Rp equal to V by R1, V by 2 by R2, V3 by R3. So here you can observe Vp equal to V1 equal to V2 equal to V3 equal to V. So that's why I am taking here. So V by Rp1, V by Rp, V by R1 plus V by R2 plus V by R3. So from here, so V equal to IR, I equal to V by R. So from where we took this formula? From Ohm's law. So at constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to IR, I equal to V by R. So from there we took that formula. So by that V by RP equal to V by R1 plus V by R2 plus V by R3. So now we am taking common, we get cancelled. 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So I am taking this one. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n. Rp equal to R by n. So I hope it is very clear. Now heating effect of electric current. Heating effect of electric current. So V equal to W, W by Q, V equal to W by Q, W equal to V into Q, V into Q. So P equal to rate of doing work, P equal to rate of doing work. So W equal to V into Q, VQ by T, P equal to V into Q by T. So now Q by T is what? Current. Q by T equal to current I, Q by T equal to current I. So P equal to V into I, P equal to V into I. Now you can observe, so E equal to P into T. So that is H, heat produced in the conductor. So Vi into T, V equal to IR, IR into I into T. So in the place of V, I am writing IR, V equal to IR. Okay. So then we can consider here. So H equal to I square RT. H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So V equal to potential difference. V is nothing but potential difference. V equal to W by Q. So W equal to you can cross multiply W equal to VQ. So we can take power equal to rate of doing work. P equal to W by T. So W equal to V into Q by T. Okay, so P equal to V into Q by T is nothing but current. So P equal to V into Q by T, that is current. P equal to VI power. Okay, so now the energy is given to the conductor is P into T. So here that is nothing but heat produced in the conductor. H equal to Vi into T. V equal to IR. IR into I into T. So H equal to I square RT. So this is about heat produced in the conductor. Okay. So now we'll do problems related to current. Try to do it. So I'll write one question. Try to do it. Four resistances of 2 ohm each of 2 ohm each are are joined joined to form a square ABCD square ABCD. Calculate the equivalent resistance of the combination between any two adjacent corners. So adjacent corners. Can you try to do it? This problem. Four resistance of 2 ohm each are joined to form a square. So four resistance of 2 ohm each are joined to form a square ABCD. Calculate the equivalent resistance of the combination between any two adjacent corners. So try to do it. So I'm giving time. So here you can observe. So this is A and this is B. So here I am considering like this. So A, B, C, D. And so here you can observe one point. Here you can observe. So 4 resistance of 2 ohm each. So here 4 resistance of 2 ohm each. 4 resistance of 2 ohm each join to form a square ABCD. ABCD. So 2 ohm. So here you can take 2 ohm, 2 ohm, 2 ohm, 2 ohm. Okay. So calculate the equivalent resistance of the combination of between any two adjacent corners. Any two adjacent corners. So I'm taking these two AB. So these three are in which combination? Series combination. So series combination means you have to add all. So then I'm taking here. So here 2 ohm and remaining A. So here I got, so this will be 2 plus 2, 4, 4 plus 2, 6, 6. So these two are in parallel combination. So whatever I got, those two are in parallel combination. So that's why 1 by R P equal to 1 by 6 plus 1 by 2. If you are taking LCM 2, so 1 plus 6. So 1 by RP equal to 4 by 6, RP equal to 6 by 4, that is nothing but 1.5. Okay, so resistance, right? Ohm. I hope it is very clear. Yes. So thank you so much for joining and attending and listening my class. So we'll see in the next class. Do like, share and subscribe to Student the Brand. We'll do problems. So electricity related problems will do it. I'll explain the concept. So there are so many models are there related to electricity topic. So continuous classes will be going on now onwards. So day, morning, so daily, everyday classes will be there. Okay, so join to the classes, attend to the classes, listen to the classes. So if you like the content, if you like the channel, if you like my explanation, do like, share and subscribe to Student in the Brand. Thank you so much for joining and attending. And go and watch so remaining videos related CBSE grade 10 physics, and videos are available. Okay, so short videos are available. Go and check. Thank you so much. We'll see you in the next class. Thank you.